Hey guys, in this video we are going to be looking at quadratic inequalities. So we'll start off with an example like this. Let's say x squared is less than 25. Now, like in the inequalities for linear ones, what we do to one side we should also do to the other. However, one of the most tempting things that people will do here is just go off and say x is less than 5. This is a big no-no. Don't do it, please. The reason for this is, whilst it's true that if x is less than 5, x squared will be less than 25. However, there are also some examples where that is not necessarily the case. So if I take an example of minus 6, if I let x equal minus 6, well, that is less than 5, so it does fall in the region. But if I square it, well, I get 36. And 36 is definitely not less than 25. So we've got a problem. We've got a problem. So it's not as simple as just square root both sides. What we should do is this. I'm going to take away 25 from both sides and say x squared minus 25 is less than 0. Whenever you're solving a quadratic inequality, you want to always make it equal to 0, or not equal to, but less than 0 or greater than 0, depending on what the sign is. Now we have the quadratic inequality x squared minus 25. Now, what we want to do is consider, imagine if x squared minus 25 were equal to 0. This is where we consider the critical points. And we can solve this by factorization. This is a difference of two squares. So we have that x squared is the same as x minus 5 times x plus 5, and that's equal to 0. Which means the solutions would, or in our case, the critical points would be when x equals 5 and when x equals minus 5. Okay? So what we're going to do, now we can factorize this x squared minus 25 to x minus 5, x plus 5. I'm actually just going to draw the graph of x minus 5, x plus 5. Okay, so we now know that if this were equal to 0, it would be going through the points x equals 5 and x equals minus 5 on the x-axis. And because it's a positive quadratic, positive x squared, we get a curve that should look something like this, where this is minus 5 and this is 5. Okay, now remember, in terms of the curve, we were interested in x squared minus 25 being less than 0, and we have this factorization being less than 0. So we want the region which lies below the x-axis. So between here and here, so everything in between. Let me just make that clear with a different color. So this is the bit that we want. So we want that x is less than 5, but at the same time greater than minus 5. So we can write that like this. We can say that, well, let's write this first. So x is greater than minus 5 and x is less than 5. To put that together, we combine that to say that minus 5, x and 5, and we use this symbol like that. So minus 5 is less than x, and x is less than 5. So this would be our final answer. Let's go through another example. So another example would be something like this. Suppose you had the inequality 2x squared minus 11x